Is my screen visible now? Okay. Okay. Yes, so I was talking about these addresses. The bit addresses of every register for bank 3 is written here. It is written here. For bank 2, it is written here. For bank 1, it is written here. And for bank 0, it is written here. For example, if I'm taking register R4, for bank 0, the bit address is 04H. For bank 1, the address is 0CH. For bank 2, the address is 14H. And for bank 3, the address is 1CH. Okay, so that is the meaning of this particular table where you have to understand. Yes, you have to by heart this. This is simple because it is a continuation starting from 0 to 7, 0 to 7, 0 to 7, then 08 to 0FH, then 10 to 17, and 18 to 1F. Okay, so if sometimes the question is asked, you should know this. So we have done this also. Then we have seen the bit addressable area. Yes, something more on the general purpose RAM. Yes, let me tell. Am I audible? Am I audible? Okay. So now I think I haven't talked much about the general purpose RAM. So where is your general purpose RAM? Please see here. Yes, your general purpose RAM is here. Your general purpose RAM is here. So I have to talk about this general purpose RAM. Okay, I have to talk this general purpose RAM. So what is the significance of the general purpose RAM? That thing we will see. So when you talk about the general purpose RAM, this is mostly associated with your stack pointer. Okay, tell me the size of a stack pointer. Tell me the size of your stack pointer. Stack pointer is used to point to the address location of a stack memory. So what is the size of a stack pointer? What is the size of a stack pointer? Stack pointer SP stack pointer. A stack pointer register 1 byte. Yes, 1 byte या फिर 8 bit. Stack pointer is of 8 bit या फिर 1 byte. Now this stack pointer, I have told you that it holds the address of the memory location of a stack. मैंने ऐसा stack बनाया था. मैंने आपको बताया था कि whenever you put up the data, it will pile up. That is why it is called as a stack memory. And it works on the principle of LIFO, last in first out, या फिर फर्स्ट इन लास्ट आउट. सो ये जो एड्रेस लोकेशन है, ये एड्रेस लोकेशन कहाँ पे स्टोर होता है? ये होता है स्टैक पॉइंटर पे स्टोर. And now I'll be explaining you that stack pointer is residing at the general purpose RAM. It resides in the general purpose RAM. So if I ask you, tell me the size of general purpose RAM, the address is from 30H to 7FH. That means there are total 80 locations are there. There are total 80 locations, or you can say 80 bytes. Yes or no? Can I say 80 bytes? Can I say 80 bytes? 80 location बोले तो 80 bytes. Yes or no? General purpose RAM. Am I audible? मैंने आपको बोला कि जनरल पर्पस रैम का स्टार्टिंग एड्रेस है 30H और उसका एंडिंग एड्रेस है 7FH. इसका मतलब देयर आर टोटल 80 लोकेशंस. 80 लोकेशन नथिंग बट कैन आई से 80 बाइट्स. कैन आई से 80 बाइट? Each location of 1 byte. So total 80 location will give you the total memory size of 80 byte. Yes or no? Yes or no? Yes. So this general purpose register is used to store temporary data and intermediate results. The main function is to store temporary data and intermediate results. Okay, and the advantage of using this memory is that their access is faster compared to the RAM. This is very important. I think I have explained you this also. If your 8051, if your if your 8051 is here, it has it has internal RAM. In this internal RAM you have, you suppose this is your internal RAM. Out of this internal RAM you have a general purpose register. The size of general purpose register is of 80 byte, and as you know that it holds the temporary data or the intermediate result. Now what is the advantage of this is that your 8051 contains your ALU, so the data which is required will be taken from the general purpose register. So this is the advantage if I compare with the external RAM. If I talk about in relation with the external RAM, external RAM also has the data, but to access the data from the external RAM it will take time. So if the data is available in the internal RAM in the general purpose register, then for 8051 it will be a easy task. Accessing the data from internal RAM will be the simpler, it will be faster as compared with accessing the data from the external RAM. I hope this is clear. I hope this is clear. Yes. Yes. Am audible?
Yes, sir.
You have to speak out fast. So this general purpose RAM is used to access the or it is used to store the temporary data or intermediate data, and this is helpful for the 8051 to access the data because it is faster to take the data from the internal RAM as compared with the off chip RAM. Off chip RAM का क्या मतलब होता है? External RAM. Now this area of memory is also used as a system stack. तो ये जो मैंने stack बताया था ना, so ये जो stack है that can be also available in the general purpose RAM. तो जो भी stack का, जो भी मैंने stack pointer का जो भी मैंने आपको बताया और जो भी मैंने stack के बारे में बताया, that is applicable for general purpose register, that is applicable for the general purpose RAM, that is applicable for the general purpose RAM. Now tell me, even I have told you, whenever you turn on your 8051, your stack pointer will hold the value of, by default, whenever you turn on your 8051, the default value of stack pointer will be,
07.
yes, 07h. It is written here 07h. It is written here 07h. So can I say now, all of you pay attention, this is important. Can I say your stack pointer will hold the starting address of 07h? So let us see where is your 07h. Let us see where is your 07h. See your 07h, all of you now. Yes, see your 07h. Can you see your 07h? So by default, your stack pointer will hold the address of 07h. यानी आपका stack pointer will locate at 07h. Can I say it will locate at R7 register of register bank 0? Yes or no? Can I say it points to the R7 register of register bank 0? Yes or no?
Yes, sir.
Yes. तो जब भी आप 8051 को ऑन करते हो तो तुरंत आपके स्टैक पॉइंटर में 07 जाता है. इसका मतलब इट पॉइंट्स टू 07h लोकेशन, बट दिस लोकेशन इज रिजर्व फॉर R7 रजिस्टर ऑफ रजिस्टर बैंक 0. दैट इज एज सिंपल एज इट इज. ओके. बट योर स्टैक पॉइंटर जो है विच इज ऑफ 8 बिट, you can put any of the value ranging from 002 ranging from 002 7fh, ranging from 00 to 7fh. So that means your internal RAM can be considered total. Your internal RAM can be considered total as a stack. Can be considered total as a stack. Okay, can be considered total as a stack. But most of the time, we will use stack from where? From general purpose register. That is the meaning of this. Mostly, we will take the stack from the general purpose register, because general purpose register is used to hold the temporary data or the intermediate data. ओके, तो हम यूजुअली ये यूज करेंगे. बट इट योर स्टैक पॉइंटर कैन होल्ड द एड्रेस फ्रॉम 00 टू 07 00 to 7fh. That means the entire internal RAM. And when your stack pointer whenever you are powering on, whenever you power on your 8051, your stack pointer will by default will hold the address of 07h. That is nothing but R7 register of your register bank 0. That is the meaning. That is the meaning of this. Any questions so far? Any questions so far? Any questions so far?
No, sir.
Okay. So this is about the general purpose register. That is about the general purpose register. Okay. Now, uh, okay. Now, even I have told you about the stack pointer, that how do you put up the value in the stack pointer by using either push and call. So it is written here. You can either, how do you push the value into the stack? By using push or call. How do you retrieve that? How do you retrieve that value? By using pop and ret. That means push and pop will go together, and your call and ret will go together. So these two will go together. These two will go together. This is used to store the value in the stack pointer. योर वैल्यू इन द स्टैक पॉइंटर. और मैंने ये भी पता है कि आपके स्टैक में आप जब जब डेटा डालोगे, आपका ये स्टैक पॉइंटर सपोज यहाँ पे आपने डेटा पहले ये डाला, बाद में आप नेक्स्ट डेटा डालोगे तो एसपी योर स्टैक पॉइंटर विल इंक्रीमेंट बाय 1. बाद में आपने ये डेटा डाला, बाद में आप अगेन आप योर स्टैक पॉइंटर विल इंक्रीमेंट बाय 2. तो यहाँ पे एसपी है, एसपी प्लस 1 है, ये एसपी प्लस 2 हो जाएगा. देन अगेन यू विल put the value. So putting the value, or sorry, not putting the value, but आपका ये जो स्टैक पॉइंटर है, ये जो इसमें जो आप वैल्यू डालते हो एसपी में, दैट इज बाय यूजिंग पुश और बाय यूजिंग कॉल. एंड आप जब वो वैल्यू रिट्राइव करते हो, आई एम टॉकिंग अबाउट द वैल्यू ऑफ एसपी. इसकी वैल्यू नहीं, इसकी बात नहीं कर रहा हूं मैं, स्टैक पॉइंटर की. तो स्टैक पॉइंटर में जो भी वैल्यू रहती है, दैट इज बाय यूजिंग पुश और कॉल. और वो स्टैक पॉइंटर की वैल्यू जब आप रिट्राइव करना चाहते हो, देन दैट कैन बी यूज्ड और दैट कैन बी रिट्राइव्ड बाय यूजिंग पॉप इंस्ट्रक्शन और बाय यूजिंग आरईटी इंस्ट्रक्शन. इज इट क्लियर टू एवरीवन? Is it clear to everyone?
Yes, sir.
Okay. So stack pointer is important. Stack is important. Stack pointer का एड्रेस यानी आप 00 से 7f तक ले सकते हो, बट यूजुअली वी टेक फ्रॉम द जनरल पर्पस रजिस्टर. Okay, so that is the importance of general purpose register. Okay, now yes, this is important. After this I'm going to end up. Please pay attention now. So you know that you have an internal ROM which is of the size of 4K. That means to access the memory address of the internal ROM, you have to go from 000 to 0FFFH. Sometimes it may require that your program size is greater. So other than on-chip ROM, you also require external ROM. You require external ROM. So you will be using the memory address 0FFF के बाद क्या address आता है 1000. So from 1000 to FFFF, this is the external ROM. So I mean to say that partial program will be stored in on chip ROM and partial will be stored on external ROM. So if you see the starting and the ending address. So if I have to use this scenario, then in that case your EA bar should be positive. EA bar is nothing but external access. EA bar is your one of the pin of 8051. जब हम pin configuration देखेंगे तब हम EA bar देखेंगे. So when your EA bar is connected to VCC या फिर आप बोलो अभी यहाँ पे EA bar क्या है, एक्टिव लो है, तो अगर मैं उसको +1 देता हूँ, इन दैट केस यू कैन गो विद दिस सिनारियो. सिनारियो क्या है, आपके पास ऑन चिप रॉम है 4K का और रिमेनिंग जो रॉम है वो आप एक्सटर्नल लगा सकते हो. कोई मुझे बता सकता है ये इसकी साइज क्या होंगी? अब जब ये आपका 4K है तो इसकी साइज क्या होंगी, एक्सटर्नल रॉम की साइज क्या होंगी? दिस इज सिंपल नाउ. See the starting address and the ending address. Now give me the answer. Starting address and the ending address. With this, I'm going to end up my lecture. I want, अगर आप जल्दी आंसर दोगे तो I will be able to wind up fast. See the starting address and the ending address. Your on chip ROM की आप जो internal ROM है वो 4K का भी यूज करते हो, तो मुझे बता सकते हैं तो ये वाले कितना कितना साइज रहेगा एक्सटर्नल ROM का? Am I audible?
Yes, sir.
तो मुझे बताओ ना, what could be the size of external ROM? I don't understand why you don't use your brain to give me the answer.
60K.
वो वही तो 60K ना, इट इज एज सिंपल. 00 से FF जा रहे हैं उसका मतलब यू कैन एक्सेस 64K. 64K में से 4K तो ऑन चिप का रॉम है, तो -4K चला गया तो बच गया 60K, तो ये आपका 60K हो गया ना? यस और नो?
Yes, sir.
सो इतना टाइम क्यों लग रहा है आप लोगों को आंसर देने? So that means when you are, I'm repeating last time, whenever EA bar is connected to VCC या फिर positive, in that case you can access your on chip ROM of 4K as well as external ROM of 60K. लेकिन मैं चाहता हूं कि मुझे पूरा का पूरा external ROM यूज करना है. Okay, in that case if you are keeping your EA bar is equals to 0 या फिर EA bar is equals to ground, then you can access external ROM of tell me the size.
64K.
Yes, 64K. See the starting address, see the ending address. Now this is clear. It totally depends upon what is EA bar. ये EA bar का जो पिन है 8051 का, इसको आपने VCC को लगाया है या फिर आपने इसको ग्राउंड किया है. Depending upon that, you will use you will access on chip ROM of 4K and external ROM of 60K. And or if your EA bar is grounded, you are accessing complete external ROM of 64K. I hope you have understood this. I hope you have understood this. Yes or no?
Yes. Yes.
Okay. I think we can stop for today. अटेंडेंस के लिए आए थे क्या?
Yes, sir. Attendance time.
हाँ,
Sir, मैं लिया हूँ.
ले लिया ना अटेंडेंस मनप्रीत?
हाँ सर.
हाँ मनप्रीत, जिन लोगों का मैंने एब्सेंट बोला था वो नंबर मुझे भेज दो, उनके नंबर रोल नंबर मुझे भेज दो, ठीक है? Okay, we will stop for today. We will meet in the next lecture. Thank you.
Thank you, sir. Thank you, sir.
Okay.
Thank you, sir. Thank you, sir.
Okay.